I can interpret key features of a linear function from a graph in terms of the real-world context it represents. Here's what you need to know. Your slope and your intercepts represent very key information about a real-world situation. Your slope, just as a refresher, is the change in the y values divided by the change in the x values. The slope describes how your output changes as your input changes. Your x-intercept tells you what has to happen in order for your answer or your output to be 0. And your y-intercept tells you what happens when your input is 0. So in this example, this graph is showing the height of a plant in centimeters m months after Gavin purchased it. So we see that we have a certain number of months that are passing by, and the height of the plant is changing in respect to that time. Our x-intercept -7, 0 means that 7 months before Gavin bought the plant was 0 centimeters tall. So since M stands for the number of months after Gavin purchased it, when the M is -7, that means it's 7 months before he bought it because of the negative value. The height of my plant is represented by the y, or the up and down axis right here. And my y value is 0. So maybe it was a seed, or that's when the plant was actually planted, was 7 months before he bought it. My y-intercept up here at 0, +28, means the day that Gavin bought the plant. So 0 months have gone by since he bought it. It's the exact day that he bought the plant. The plant was 28 centimeters tall when he bought it. Our slope is going to be the change in the y, or the change in the height of the plant, divided by the change in x, or the change in the number of months that has gone by. So you can choose any 2 points that you would like to for this. I'm using the intercepts because they're already labeled, and I'm plugging into my slope formula. So the difference between my y's divided by the difference between my x's gives me 28/7, which simplifies down to just be 4. So that tells me that every month, every 1 month that passes, the plant grows 4 centimeters in height. Let's do an example. A soda company buys 400 ounces of syrup to use for sweetening their sodas. The large soda bottles require 16 ounces of syrup, and the small soda bottles require 4 ounces of syrup. Let's figure out what the intercepts mean and what the slope means for this situation. We're going to start by writing our function. Let's let x be the large bottles, y be the small bottles. Here is my function, and we're also going to graph it. We did this in a previous video. Here's the graph of that function. And again, these points were found by plugging in 0 for each of the different variables x and y, and then solving for the other one. Those are my intercepts. So now let's analyze this. What do the intercepts mean? Take a look at these points, 25, 0, and 0, 100. The x-intercept 25, 0 tells us that the company can use 25 large and 0 small bottles. That's one possible combination of bottles that would use up all 400 ounces of syrup. My y-intercept tells us that the company could also do 0 large bottles and 100 small bottles instead. That's a different combination of bottles the company could use to use up all 400 ounces of the syrup. Let's also figure out what the slope means. So I'm going to use these intercepts to plug into my slope formula, and I get that my slope is -4/1. So every single time that the number of large bottles, because that's my x on the bottom right here, when my x value changes by 1, the number of small bottles, or the y value up here on top, goes down by 4. So every time I want to use a large bottle, I have to swap that out for 4 small bottles instead. Every time I want to use a large bottle, I have to sacrifice 4 of my small bottles instead. So the company just loses the ability to fill 4 small bottles every time that they do 1 large bottle. Go ahead and pause and try this one. We've done this in a previous video. We do have the function that represents the number of pages left to read each day. This is the function right here. Let's graph it and figure out what our intercepts and our slope represent. I've got my intercepts 0, 300, and 6, 0. The x-intercept 6, 0 just tells us that the number of days is 6 and the number of pages left is 0. So on day 6, Kale has 0 pages left to read. The y-intercept 0, 300 tells us that on day number 0, or at the very beginning, Kale has 300 pages left to read. So on the day he starts reading at the beginning of the book. My slope can be calculated by plugging into my slope formula, and I get that the slope is negative 50 over 1. Remember what your variables stand for too. That's helpful when you're doing this. So the change in y, we said that y, or f of x, is going to be the number of pages left to read, and x down here is my input variable. That's the number of days. So I know that there are 50 pages fewer to read every time the days go by. So every time the number of days increases by 1, the number of pages left to read decreases by 50. Each day he has 50 fewer pages left to read. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.